Materials. Today we are gonna learn everything you need to know about the material components in TresJS. It is extremely easy. You just go here to your scene and you change normal material for Toon material. And voila, you have a different material. And that's everything you need to know. Happy coding! Okay, no, there is way more things actually that we can talk about materials in this tutorial. The best way I can explain you what a material is just by using this analogy. So think of my shirt as a geometry. I can just change its color like this or like... So the geometry keeps the same, but the color of the material has changed. It's exactly how it's done in 3D. You probably remember this diagram from the previous video about geometries, where we explained that the geometry is just basically an amount of vertices or points that are interconnected forming a geometry. And the material is just basically the visual properties. So material is a shader. A shader is just a program where you code how each pixel is gonna look like. So imagine that you program that has dots, then the final result of the geometry plus the material will have dots because you are assigning a different color to these pixels. Writing shader is quite complex. It requires a lot of practice and I actually have some videos about it. But today we're gonna use some of the built-in materials that Three.js have under the hood. So TresJS, we can use them as components. Let's now go back to our code and I'm going to remove this and just use the basic material. And we start from there. So the basic material is MeshBasicMaterial. You can find it in documentation on Three.js, but it's the most basic material, you know? What it does is just put a color, okay? And it doesn't react to any light, to any external factors. So it doesn't have any shading, it's just a plain color, okay? For now, I'm going to comment out the lights, okay? And we are gonna focus on the basic material. I'm gonna add another mesh, probably in the x-axis. So I'm gonna say position equal 2, probably in the x-axis, 0 and 0. Okay, let's put this. And I am going to add the torus, only a torus one, okay? So these two, I don't remember if it was like this, but let's check it out. Okay, they're way too much together. So let's put it like 4 or 5. Yeah, 4. Check out. Yes, a little bit better. Okay, cool. Let's change the color and say something like pink for the torus material, so for the donut. Okay, we have something better here. So let's talk about the props that are inside of any material, okay? Because these all are inheriting from a class called material. So the basic material and all the rest of the materials that we're going to see today are just inheriting things from there. One of the things that you can set is, as we saw in the video before, it was the wireframe. So if you put wireframe to true, you're going to see how it's composed inside. Maybe this one has too many segments, so I'm going to reduce the segments so you can see a little bit better how it looks inside. Okay, but this allows you to see all the different vertices and edges that you have. Let's try another thing. So I'm going to remove the wireframe and try to change the opacity of the mesh. So to do that, we're going to go to the material, okay? And you need to put transparent to true, okay? And also opacity. We're going to put something like 0.5, okay? And we need to put here on the trace canvas that we want to render things with different alphas. So if we reload, we're gonna see now that our material is a little bit transparent. So you can see the donut right here through them, okay? We can reduce the opacity here, let's say 0.1, and it's gonna be way more transparent. Another thing that is important to mention is that for performance reasons, whenever you create a material, I'm going to get out these two, okay? And render the torus node again. If I go and try to go inside, you see that there are some places where the material is not being rendered. Maybe to see it better, we can just change here to a sphere. Okay, so I'm gonna put a sphere and then remove this part here. Okay, we have the sphere, and if I go inside of the sphere, you notice that it looks like there is nothing. Okay, and that's because from inside of the sphere, the material is not being rendered. Okay, you can also see that whenever you have a plane, let's put a plane here. A plane geometry, and let's put, I don't know, 1, 1, and 32, I think it is. So you see the plane here, but if we go to the other side, you see that it disappears, right? And it's because it's only rendered from one side. To tell the renderer that you want to render the other side, you can pass to the material something called side, okay? And you're gonna pass constant that is called 3 double side. That's something that you can import from 3, okay? But it's basically a constant number, so it's gonna be 2. I'm gonna remove the 3 here and try to import it here. So no, I need to do it like here. Double side, okay? So now if I refresh, we have our plane, right? And it's rendered from both sides, okay? Okay, let's see now another material. So I jump back to my torus node material, and here in the MeshBasicMaterial, let's change it for something that we have been using in this series of tutorial, which is called the normal material, okay? So the normal material is basically the representation of all the normals of the geometry, okay? So this is the one that is used to check the UV maps, so how this geometry is unwrapped. So it makes it to a 2D image, okay? It's kind of complex, and we're gonna see more about that in the next video about textures, okay? For now, just know that there is a normal material will look like this, okay? We can also have a property only for this one, I think. It's called flat shading, because right now the geometry and the material looks smooth, but in reality, it looks something like this. So let's refresh. Okay, so this is flat shading. What it's doing is basically showing how the material looks without smoothing. There is also another material that doesn't rely on the light information, and is the MeshDepthMaterial. So I'm going to replace this with depth, okay, and remove the flat shading. Okay, and right now you're gonna see it black, but this one, when you zoom in, you see now that the geometry of the material looks a little bit more light, like a light gray, right? And even white. It's because this material relies on how close the object is to the camera, okay? So the far you go with the camera, it's gonna look black, and once you zoom in and are really close to the geometry, you're gonna see it in a scale of gray until white, okay? There is not that much to know, but this one can be used for several effects, especially for fog, like in some map that you want to reduce the visibility of all objects that are far from the camera, you can do this, okay? There is another material called the MeshMatcap material that doesn't rely on lights either, But for this one, I will need to explain you how to load textures. So make sure you remember me in the next video about it, and I will put it there, okay? Let's go to the materials that rely on lights. Now let's uncomment the lights that are in the scene, okay? I know that we haven't seen anything about lights yet. It's gonna be in a future tutorial, but for now, let's use the ones here, okay? And I'm gonna remove the Matcap material, and I'm gonna add Lambert material. The Lambert material, if I save, you're gonna see that it looks like it's illuminated and it has some shadows because it's actually reacting to the lights that I have here. If I comment again the lights, you're gonna see that now the material doesn't work, it's pitch black. And it's because it needs the information of the lights in the scene to be able to render. So let's get back the ambient light and the directional light. And now we see our mesh again. We can do the same as before, like change the color, for example, and add, I don't remember the color that was here. It was 82C, this one. So if I click save, you're gonna see that now the color is applied. This is the most performant material in terms of light information, okay? But if you go really close to it, you're gonna notice there are some strange patterns happening because it's actually fake, okay? So the material is doing a great job to show it, but maybe it's not the level of quality that you would like, okay? So for that, we can use the PhongMaterial. Now we're gonna use the, I think I will pronounce it correctly, Phong. So it's Phong, like this. Okay, so if we refresh, we're gonna see that it's quite similar to the other one, but this one is less performant because it has more properties regarding the light. Okay, so one thing that we could play with is the shininess. So if I put here shininess and I put it to 100, okay, and then I set the color of a specular to, I don't know, red, okay, and we go here, oops, oh yes, this needs to be a string, red, okay. You will notice now that it has like a reflection, and this reflection is calculated using this color. So it doesn't matter what the color of the light is, this light is white. We could set the specular color to be red in this case. If I put hot pink here, it's gonna change the specular color. So that's quite cool, and it's something that you can use for tweaking the material. The more shininess you add, the more like reflective it will be, okay? Well, in this case, it's kind of weird. Let's put like 5. Now it's more like shade. It looks quite nice. You can play with those factors in terms of the light. Now is the time for my favorite material of them all, which is the Toon material. I used it at the beginning, but this is the one that I use the most. So the Toon material, I don't know if you are familiar with some games that have this cell shading kind of a shader, right? Where it looks like a toon, like a comic, where the transition between the light and the shadow is really abrupt. So here we can see like the light is really cool. I love the effect. It looks like came out from a cartoon, and is the one that I use the most. In terms, this one is pretty similar to the Lambert material, but the properties are a little bit more cartoonish. This is the one that you often see in video games like Genshin Impact that has this anime style. It's not quite the same because this is the default one that comes with Three.js. You will need to create a specialized shader with the same concept but also for the lights to be reflected and so on. But the effect is quite cool. An important thing that you must know about this material and all the materials that are reacted to the light information is that right now we have the light in a certain place, but let's say I move the light to a different position. In this case, I have it in the x-axis in -1, so I'm going to put it just right above the geometry. So it's going to be, let's put 4 here and 0 here and see what happens. So you're now going to notice that the light comes from the top and the shadows are now rendered below the geometry where the light doesn't sit. So these calculations is what makes it less performant, but this allows you to have interactive geometries where the lights could change from place and then you have updated shadows and so on. Okay, I'm gonna also do the same for the donut. Now that we're here, I'm gonna add Toon Material, and now you're gonna see that it looks way cooler. Okay, and the light information is coming from top. Okay. Okay, time to get real. Now we're gonna see the materials that are used for more realistic scenes. Okay. In this case, I'm actually going to use the documentation from Three.js to explain the MeshStandardMaterial and the MeshPhysicalMaterial. So the standard physical material is using something called the metallic and roughness workflow. You can define how metallic it will look and how rough or like how polished the material is. This is used for physical basic render or PBR. That is a standard in many 3D software like Unity, Unreal, and Blender, for example. We're gonna see more of that in the next episode about textures, okay? And it has a lot of info. So for now, let's talk about the materials themselves. Here there is a lot of documentation that you can take a look of it, like how it works under the hood. Also, I didn't know, but the PBR systems can be found in a paper from Disney. So it was actually original from Disney. I didn't know that. Here we have a torus node similar to the one that I have in the scene. And this one is using a standard material. So in the standard material, you can change just the color, but you have way more properties that you can tweak. In this case, you can change the roughness. So if you change this one, you're going to notice now that it looks plastic because you're changing how polished it looks. You can also make it really metallic, changing the metalness here. But it's not really visible if you don't have something called environment maps. Actually, we can fake one here, okay, of the city. And look how it looks, the metallic of it. Actually, let me just increase the ambient light. So I'm gonna use white, okay? And you're gonna see now that it's way more visible, the roughness. So if I increase to 1, it's completely rough, so you don't see any reflections. And if I go down and go to 0, you're gonna see like a plastic. If I go here, totally plastic with the metalness, and if I go really up, I can even fake a gold color like this. Let me say, it will be something like this. So this is how you will do a metallic gold or silver material, okay? Now that we learned this from Three.js, let's see how we can use it in Tres. So in Tres, you're gonna use a standard material, okay? And let's keep the same color. So at the beginning, it's gonna look pretty much the same as the Lambert and PhongMaterial, but this one is way more realistic. Let's pass the roughness. So in the roughness, let's put something like 0.1, and immediately you can see the reflections of the lights, or tres directional light that we have. This one has really low like intensity. So I'm going to add a little bit more intensity here, okay? And now let's add the metalness. So the metalness, let's say something like 1. So it's completely metallic, and you're gonna see that now it's really like dark, right? So let's put something like 0.5 here, okay? And now it's supposed to be more metallic, right? But it's really difficult to see it with these colors without an environment map, okay? So here, let's put gold. oof, that's not the goal that I was expecting. It looks more like something. Yeah, I'm not gonna say it. Let's put silver or bronze. Bronze. I prefer bronze. Oh, bronze doesn't have a color? I didn't know that. Or it's because no, I think I'm writing it wrong, right? Oh no, it doesn't have a color, but silver does. Huh? Funny though. Okay, so if I put one here, way too dark, 0.9. It's always playing with the numbers here. Okay. And with the roughness, let's go 0.05. Okay, it looks how it affects how reflective it is. If I put something like 5. Okay, it looks way more. Oh, maybe the metalness, I needed that. Oh, it looks completely like mate. Nice. So this is how you can achieve a little bit more of a physical material, but there's actually another one that is called physical material. Okay. And the difference is, let me search for it. We have the material here, standard. Let's search here for MeshPhysicalMaterial. So this one is an extension of the standard material that provides another physical based properties. Okay, so it adds the clear coat, like car paints, carbon fiber, and wet surfaces. Nice. Advanced reflectivity, physically based transparency. Have no idea what that means, but cool. Actually, we can play with the things here. So I'm gonna add environment map real quick, so we have a reflection, and probably change the light color here. And now let's play with the color. Let's put something like this, like this. So metalness and clear coat. Oh, clear coat looks like it looks like paint. Lol. If you put more metalness, it looks like this, but it looks like paint. So this is the clear coat. Okay. And how rough is the clear coat? Makes sense. Flat shading, fog. Emissive. Yeah, there is another thing that is called emissive, and this is when you want to create like a light, okay? But for now, yeah, visual alpha test. For emissive material, let's see if we can actually fake it. So emissive intensity equal to, and emissive, it needs to be a color. So I'm gonna say like red. Let's see if it works. Okay, so normally it's a color that it will look like a light, but like it was an object shining or glowing. But in this case, since we don't have post-processing already in the scene, it's gonna be really difficult to use bloom and see the effect happening. Maybe if I reduce the light, but I don't think we're gonna see it. No. Okay, so also you can check all the different properties that are available here. So like with TypeScript, you're gonna see it's also complaining because it should be in a new line. Something's wrong with my ESLint. But you have all the information for the TypeScript support here, and you can check like the different things that it accepts. In this case, emissive is the color. And if we put intensity here, you have the autocomplete, and it's gonna tell us that should be in a new line. Okay, please. Happy? And what it has, I don't know why it's complaining. So read only a number. Okay, is a read only number or undefined? So we can pass the. You see, my printer is messing up with the ESLint. It's so annoying. Sorry about that. I hope it doesn't affect the quality of the recording. There are also other materials, so you can go to the documentation and find the list of all the materials in Three.js docs. But we're gonna stop from now because there is another one called the shader material and raw shader material, which is too advanced for the sake of the scope of this tutorial. So let's keep things basic, and now you can play with the different materials and set some color into your geometries affecting the shaders, okay? So, and that, chamos y chamas, is everything for today's video. Please make sure you subscribe, drop a like, and comment in the section below so we can continue feeding the guts of the algorithm. Not really, subscribe. I need it. Next video, we're probably going to touch or light or textures. So let me know in the comments which one you prefer, and if you would like a specialized, more advanced video about shaders in TresJS. So happy coding and continue doing 3D with you.